So another important principle is solution dilution. That's when you take a more concentrated solution and you make less concentrated solutions from it. Now, the more concentrated solution is what we call a stock solution. There's a lot of reasons why we might want to work from a stock solution. The first is really the fact that some solids don't dissolve quickly and can take days to get into solution. So what we do is we make this more concentrated solution so that when we need the less concentrated solution, it's very easy to take and make a solution from that because it's already dissolved. So we take a stock solution, all right, and we add it to a flask. For example, we have this 0.15 molar 0.15 liters of 10 molar stock solution that we add to a 3-liter flask. Now, I just wrote that on the slide beforehand because it wasn't on the slide before. And so what we're doing actually is we're adding 1.50 moles to this flask because 0.15 liters times 10 moles per liter, right, gives me the 1.50 moles. So I have that in the flask, and then what I do is I fill it up to the mark with water. Now the water doesn't have any of the solute in it, so all you're doing is adding to the volume. And if you remember, the concentration is the moles of solute, right, over liter of solvent. And so what you've done by adding the solvent to it is created a more dilute solution. So in principle, and I don't want you to use this equation all the time, what I've done is on this side, the moles is the molarity times the volume. It turns out the moles on this side is also the molarity times the volume. But this is molarity 1 in volume 1, and this is molarity 2 in volume 2. And what you have is an equation that you can use in dilution that allows you to quickly calculate the molarity of another solution. So I have M1 V1 is equal to M2 V2, like that. Given 3 of any of those, you can calculate the fourth. So here's example, and I'll go ahead and work this one out using moles and volume, then I'll try using the equation on it. Okay, so what volume of 12 molar stock HCl is needed to prepare 250 milliliters of 0.300 molar HCl? So where you start these problems from are whatever two numbers that allow you to calculate moles, and we know moles comes from the molarity and the volume. So that's what I'm going to get when I go to here. Okay, those two I have molarity and volume, and from that I can calculate moles. So let's go ahead and calculate the moles of HCl that we're going to be diluting down. So 250 milliliters, right? So I want moles. 250 milliliters. 0.0 milliliters. I need to get that into liters, so that's going to be 1 milliliter, right, is 10 to the minus third liters, and then I'm going to multiply by 0.3 moles of HCl per liter. Again, just to get the units to work out like that. Okay. So that comes out to be 0.0750 moles. Now, if I have the moles, right, I can use this 12 molar as a conversion factor to get me to liters. Again, you have molarity, volume, and moles all working together, and I'm trying to find the volume of HCl. And so it's going to be times, and remember, when you have 12 molar, that's the same as 12.0 moles per liter, like that. I need to get the moles to cancel out. So what will happen is I'm going to go 12.0 moles per liter. My moles will cancel out, but I need the answer to be in milliliters. So again, I have to do my milliliter conversion, and then 1 milliliter is 10 to the minus third liters, and I can put that in my calculator, and that comes out to 6.25 milliliters. Now, let's say you wanted to use that equation, the M1 V1 is equal to M2 V2. That's a great way to guide you through the calculation. So let me rework this whole problem and show you how you'll have to do it if you use that equation. Okay, so let's start with our equation. It's M1 V1 is equal to M2 V2. And this works great for dilution problems. So we're going to go, okay, what's my M1 and what's my V1? Now, it doesn't matter which one you call 1 and 2. It'll always leave you, if you have 3 of them, it'll always leave you with 1 to solve for. So let's say, for example, I call this molarity 1 and this volume 1, right? That would mean that molarity 2 would be this one. And the volume that I'm looking for is volume 2. So now, to use the equation then, I just have to identify the variables and then plug them in with the appropriate units. So what I'll need to do is convert 250 milliliters. Well, let me write it out like this. M1, V1, M2, and V2. And I'm going to just find these values in the problem. So it's going to be 250 milliliters. This is going to be 0.300 molar, and again, write that out as moles per liter because it really does help you work with units better. And then M2 is going to be 12.0 molar, which is again moles per liter, and my volume, that's what I'm looking for. Now when I write out the equation, I can write it out as V2 is M1 times V1 over M2 like that. I'll solve it that way. And then what I have to do is I have to get my volume into liters. So I'll be going like this. It's a 1 milliliter is 10 to the minus third liters. And then I'll do the calculation real quick. So that's 0.2500 liters like that. Now what you can do is you can just plug it into the equation. And that's going to be 0.300 moles per liter times 0.2500 liters. Now my liters will cancel out and leave me with moles. And then I'm going to take and divide by my 12.0 molar, which is moles per liter like this. So the moles will cancel like this, and this will flip over to the top. Now when you do that, you're going to get 0.00625 liters, which then has to be converted into milliliters. So I have this answer down here now, and so that's going to be 0.00625 liters, but I know I have to have it in milliliters, so I'll go ahead and go 1 liter and then 10 to the minus, 1 milliliter is 10 to the minus third liters, and that'll come out to 6.25 milliliters.